Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, thank you for choosing IT Pro TV, helping you learn everywhere you go. I'm Zach Memis, your host, as we continue on with CompTIA Net Plus. This episode is Network Performance Concepts, and Wes is right here to show us the way. Wes, good to have you.
Hey, Zach, thanks for having me back. That's right. You know, we have been working through essentially a few concepts when it comes to routing and switching. We've looked at things like, the characteristics of our traffic, some of the properties that you have to be aware of. We've talked about things like broadcast domains, the communication types. We looked at switching technologies. We've also looked at routing concepts, too. And as we've moved through those different shows, we've been looking really at that 1.3 domain there, if you're following along at home with the objectives there, and it is the basically understanding the concepts of routing and switching. And we kind of divvied them up a little bit so that we could group them together in what I feel is in the appropriate manner, right? Because when we're talking about switching technologies, we're talking about VLANs, right? Well, that should be grouped together with the switches. And if we talk about something like routing information protocol or OSPF, that should be part of our routing technologies, right? So one of the last things that we kind of want to, again, if you've been following along with us, one of the last things that we kind of want to round off are some network performance concepts, just like Zach said here. And we're going to look at how you can manipulate your communications a little bit to ensure that different types of traffic get the network resources they need. Because when you think about it, we've got a network, we've got a certain amount of bandwidth, and we sometimes need to prioritize, what types of traffic get to their endpoint closer to real time, if you will, and maybe even like some traffic, right, traditional and old traffic that we can slow down a little bit to ensure that real-time traffic gets where it needs to be on time.
So that sounds like network shaping, right?
It's close. It's called traffic shaping, all right? And in fact, what we're going to look at is more of an umbrella term, right? Well, we call it quality of service, right? And quality of service really is, there's many different ways we can achieve a quality of service. But imagine that you've got, let's say one communication, and it's hogging all of your bandwidth. Let's say, for instance, somebody is on your network viewing things like YouTube, right? When maybe they should be working. And what's causing, it can cause problems with things like voice over traffic, voice over IP communications, right, in which we need to kind of ensure a faster delivery. Well, if somebody's hogging all of our bandwidth in a certain area, then what happens is the end user experience starts to degrade, right, and certain communications, we start to notice performance hindrances inside of our network.
So traffic shaping can affect our network performance.
It can. And we need to kind of understand what's going on here when it comes to traffic shaping. Now, traffic shaping can be broken down into some categories as well, right? For instance, on your exam objectives, they call out what is known as traffic shaping, and they also mention a little bit about what's known as policing. Actually, they just call it traffic shaping, really, but again, I'm going to break it down into three different concepts. We're going to talk about traffic shaping itself, we're going to talk about traffic policing, and then last, I want to talk about reservations, too, because really, again, in the context of the exam objectives, they just mentioned traffic shaping. So let's go ahead and let's first give you a scenario where maybe I need traffic shaping. All right. Again, you want to ensure that certain types of traffic get the level of performance, the level of your network communications that they need in order to give a better experience, right? We have older traffic types, like some of the most common ones, and again, classic traffic types, like things like FTP, file transfer protocol, things like HTTP, right, your web traffic. Well, they can do a little bit better with a little bit of delay. I mean, HTTP might be a little exception there if you're talking about end users, right, because end users want to get to your website and they want the fastest and best experience possible. But if you look at things like file transfer protocol, been around for a very long time, and it's not necessary because it is optimized for large file transfer that it consumes all of your network bandwidth. We can actually kind of slow that traffic down, and if we look at our bandwidth as more of a piece of pie, right, we can give a greater piece of pie to things like voice conferencing, right, video conferencing, voice over IP communications, things that need to get there a little bit faster, right, because file transfer protocol, it can handle a little bit about a delay, a moderate amount of delay, right? Things like video, right? Video conferencing. It can't really handle a lot of delay, right? It needs to be closer to real time. But the other thing that we have to look at is, well, video conferencing, we can implement a little bit of packet loss, right? Because in video conferencing, I don't need to rebuild and reassemble packets, if you will, and cause like a glitch inside of the video stream that we're watching, right? Versus something like FTP, where we really can't have packet loss. Packet loss leads to file corruption, right? So we need to be able to mix and match and kind of put the pieces of our network communications bandwidth where they need them. And that's what traffic shaping, one of the many components under quality of service, traffic shaping allows us to do. So let's talk about why, a little bit more about traffic shaping. I got a little diagram here, and what we're going to do is kind of do this in the in 8-bit increments, right? We're going to say, well, if I want to shape the traffic, it essentially allows me the ability to do bandwidth management, manipulate the data in order to give prioritization to certain traffic, as well as reducing the heavy impact or the impact that heavy bandwidth users would have on any one person's experience. Like I said, if we're watching a lot of YouTube communications, then we've got unnecessary traffic on our networks, and we need to make sure that we can shape that a little bit more. So let's say that we're working on a policy, if you will, that says, hey, you can only use 8 bits of bandwidth. Well, if I'm doing traffic shaping, how does that work for us? Well, if we're talking about just basic traffic shaping, we're saying there's 8 bits of information, and that's kind of our ceiling, our cap. Well, notice that if I have 6 bits of bandwidth, what does traffic shaping do for me? Absolutely nothing. I don't even notice it, right? But how about this? How about if we send 7 bits of traffic, right? Well, how does traffic shaping affect me there on those communications? Well, it doesn't, right? If I'm sending less than whatever the cap is, whatever in the policy says, hey, you're going to send this amount and you're not going to send any more, it doesn't affect you if you send less, right? And we don't even know. But let's consider, when we talk about traffic shaping, a random line in the middle of the diagram. Let's go ahead and pull this over. Let's say, hey, well, what happens if you send 8 bits of information? Well, you're still within the policy. Nothing really happens. But here's where it starts to come into play. I want you to notice that we have this 9th bit, right? We say, hey, the cap is 8 bits. And again, we're just using this for theory purposes, right? 8 bits. What happens to the 9th bit? Well, this is where you have to know the difference between traffic shaping and traffic policing. Again, it's all really part of adjusting your bandwidth, but what happens to this 9th bit is really different when we talk about shaping versus policing. So Zach, if we look here, our 9th bit, what's going to happen to that? Well, if we go over the cap, it's going to be put in a buffer. And what's going to happen is the network adapter is going to buffer it. And it says, you know what? I can't send that 9th bit right now. So what we'll do is we'll put it in a buffer and we'll allow communication to keep happening. And when the network's free, we'll send that 9th bit. Right? That's traffic shaping. And what it says is you're not going to send any more information than just this. Now, there's a little bit more to that because I want to talk about policing, and then we'll compare the two, because what happens to that extra traffic is polar opposite different when it comes to the two different concepts. So let's go ahead and let's talk a little bit about traffic policing. Now, remember what we said. Traffic policing, we're saying 8 bits is the cap. So anything less than that, right? If I say, okay, here's 8 bits, and I say, well, somebody's sending, I don't know, let's say 3 bits of information. Well, they don't really notice it, right? And if, let's say they send 7 bits, well, just like traffic shaping, it really doesn't affect us. But now what we're going to do is we're going to play a little bit of devil's advocate, and I'm going to bring out that pesky 9th bit again. All right, so what happens to the 9th bit? You're over the cap. Now, here's the big difference. Notice when I said traffic shaping, what we do is we buffer the excess information. If it's over what the policy states, or the rule states, if you will, we're going to buffer that bit, and then when the line's free, we're going to try to keep sending that information, right? But we're going to make sure it's no more than 8 bits. Policing, it does a little bit different. And instead of doing a buffer, if you will, like we just did with shaping, right? It doesn't do a buffer. In fact, it's called policing because what it does is it takes that 9th bit and it essentially will send it directly to the garbage. All right? Electrical limbo. So what happens is with policing, any extra information is thrown out. Sorry, you can't send any more information than that, right? We're not shaping the traffic. We're not saying, okay, I just want this steady rate and anything extra will be buffered and then sent. No. Policing says, you're going to send this amount of information. If you send more, I'm just going to discard it. So that is something to understand when it comes to the difference between traffic shaping and traffic policing. Now, there's another one, too, that we have, and that's something known as reservations, all right? And what I want you to understand with reservations is that is kind of like saying, all right, well, you know what? I've got one device that's very, very important in my network. Very important, all right? And what I'm going to do is I'm going to say that this device, I'm going to reserve that bandwidth. I'm going to say 8 bits. You're guaranteed 8 bits. I'm going to reserve a portion of the network bandwidth for you to make sure that you have that 8 bits when you need it. That's reservation. It's still traffic shading. You're still manipulating the bandwidth. But you can do this in a couple of ways, right? I can say, Zach, you always are going to have time to speak here. Now, he's been hosting with us for a while now, and he knows that if I'm talking, nobody's going to be able to talk. But so it might not be a good analogy here. But
it's a hierarchy.
That's right. That's right. So I'm going to say, Zach, you know, you are going to be reserved this time. Now, what do we do with that time? What do we do with that bandwidth? Well, here's where the two differences come in. You can do a reservation that says, Zach, I'm going to reserve you that time, and it's set in stone. It's just going to be there waiting for you, and you know what? We're going to take it away from the rest of the network. So if you have a very high priority system, right, that you need that bandwidth, you need to make sure that it's always open, right? Let's say we're reserving the Bat phone. We need to know that if Batman makes that call, he's got that bandwidth when he needs it. Or we could say, same thing, make a reservation. But what we're going to do is we're going to go ahead and use that bandwidth while you're not using it, right? So it's kind of like dinner reservations, right? The table doesn't get reserved and then nobody uses it the rest of the night, right? Unless you're maybe an A-list celebrity, maybe that's the case. But notice what they do. You have a reservation for that table during the time that you need it, but then during the rest of the hours of that business, other people are going to use it, all right? Now, the difference is when the time comes, that table is cleared and it's available for you. So reservations are really no different. So understand that there's a few different ways that we can manipulate and shape the traffic. Shaping says, send only this amount of information, anything extra will be buffered, and the next time we have free time on the wire, we'll send it. Policing says, send only this amount of information, and if you send more, throw it out. Sorry, too bad, no food for you. The last one says, reservation says, we're going to guarantee you that you have this amount of information, and when you need it, it'll be there for you. Now, how? Again, like I said, it can always be ready and available, and that might produce problems, right? Because now we got a portion of our bandwidth that's not being utilized at all. Sometimes, maybe it's 20% utilization, but it's always reserved. Or we say, go ahead and use it, and when you need it, it's going to be reserved. It'll be there for you.
So a question for you, Wes. Who would use the traffic policing? It seems to me that'd be very prohibitive.
Well, it would, but this is more about control over how much information. So if you, I tell you what, so if we've got something like this, let's go back to the diagram here real quick, right? So here was our bandwidth, that our user that was watching YouTube was using prior to us policing the traffic. All right, but here is, and in fact, let me go ahead and just get this out of here, and we'll use another one. All right. Now, here is the person that was using that 9th bit, right? Well, policing, I might say, you know what, this is YouTube traffic, right? So in YouTube traffic, and I'm not picking on YouTube in general, I'm just saying because it's consuming our information during business hours, right? This isn't about YouTube, all right? But I'm going to say, you know what, YouTube traffic, I'm going to police it. Yeah. It's not important. So if you're using more of my information, I'm going to cap you there, and anything else you try to use, I'm going to discard. Versus if this was a voice over IP system, I might want to not do policing on it. I might want to do traffic shaping on it, where I say, you know what, it is an important system. So what we'll go ahead and do is we'll put that cap in there, and then voice over IP system, if you need to send it again, or maybe not even voice over IP, some other important traffic on our network, you will have access to that information, and we'll put it down there in the buffer, right? So, and again, it just allows the administrators to take this overall larger size of pie, your bandwidth, and then divide it accordingly. Okay. All right, so that's a couple of things that you need to know just about traffic shaping. Now, there are a few other terms that we need to be aware of, and one of them, like I mentioned, is quality of service. All right, quality of service is basically, like I said, the umbrella term that says, hey, I'm going to identify the traffic, then I'm going to classify the traffic, right? So we need some tools to be able to identify and classify it, but then we also need actions that are applied once we identify it, right? So for instance, if we talk about access control lists and another subject, right? I need to identify who you are first, right? As Zach, I got to say, hey, who are you, right? Well, you present me with your identification badge. I mean, even though I know Zach, you present an ID badge. It's like, okay, we've classified who you are. You're a host here with IT Pro TV. Now, what level of access do you have, right? So inside of quality of service, we need mechanisms that allow us to identify the traffic and then classify it. Identify what type is it, right? And then how are we going to prioritize it, right? So, and these are a couple of things. These are some of the things that quality of service allow us to do. And there's many different ways. There's different parameters that we can apply to our traffic in order to do that. Now, to kind of understand what we mean by that, you kind of have to look at an Ethernet frame. Remember, I'm talking about manipulating your data a little bit, right? To be able to, again, identify what type of traffic it is and classify it, based on a priority level. So let's go ahead and let's kind of dive into the Ethernet frame here that I've got, right? So this is just a standard Ethernet frame, and we'll also talk a little bit too, because one of these actually falls within a switching technology that we talked about called VLAN tagging, right? 802.1q. So here is our regular Ethernet frame, right? And kind of go through the pieces that we have here. We've got a preamble, right? The preamble is just a set of bits that allows the receiving device to synchronize their time clocks, right? Synchronization. Then the next thing that we have is what's known as the start of frame, right? The start of frame is a delimiter, just an 8-bit field, but it basically marks the end of the preamble and the beginning of the frame. That's really all it's there for. All right? Now, you probably remember that we've talked about these, right? We've got a destination MAC address, right? That tells the switch where is it going. Source MAC address says, hey, where'd it come from? Now, the ether type. Here's the ether type is interesting. You might hear it called ether type. You might hear it called length, because depending on how it's implemented, ether type just tells it tells the switch essentially what upper layer protocols are actually encapsulated inside of this frame, right? Remember, the encapsulation is happening down there at the data link layer. So the ether type just says, hey, this is the type of protocol that's encapsulated within the Ethernet frame. Or it could be used as a length, right? And it just denotes the length of the frame itself. So it can be used for either or. Now, we have our data, right? And, well, data's kind of self-explanatory there. That's the stuff that we want to send, right? All this other stuff is added to the frame so that we can get it where it needs to go. You typically have a 1,500 byte, by default, a 1,500 byte payload limit. If you don't hit the 1,500 limit, sometimes they'll put padding there. So that's just why I put padding there. It's optional. And then you have the frame checks, the frame check sequence, sometimes checksum sequence. But the frame check sequence, all that is a 32-bit value. It's technically what's known as a CRC, a cyclic redundancy check. It's for integrity checking, right? We do store and forward in our switching, all right? So that's the Ethernet frame. How do I identify this information and start to classify it? Well, this is where we get into the 802.1q. And I'll tell you what all this under my head here is in a bit. We'll get there. But now I want you to notice that we still have the same format, right? We've got the preamble, the start of frame. We've got the destination source. We'll come back to 802.1q here in a second. We got the ether type, data, padding, frame checksum sequence. So nothing different than the earlier Ethernet frame. Right. All right, but if I have a frame that needs to go to a specific VLAN, what's going to happen? It's going to add the 802.1q VLAN tag. Now, inside of that tag, we've got some interesting information. If we were to take that tag out and kind of break it down into its components and see what it looks like, you would have a tag type. This just identifies the frame as being tagged or untagged, kind of like we've talked about in other episodes, right? Tagging means it's going to a VLAN. Untagging means it's either on the destination VLAN or it's an access port. But then we have this priority, all right? And I'm going to skip over that just for a second because that's really where the action's at. That's what we're focusing on. Then you have the CFI. That's a canonical format indicator. It's not really used today. It was used for an interoperability between Ethernet networks and Token Ring in the earlier days. It's pretty much unused today. And then last but not least, Well, the VLAN identifier identifies what VLAN you're on, right? But here's where we talk about the priority. The priority essentially is used to give a frame, the priority level for different classes. And this is an earlier class of service, if you will. And you can see that within these bits, we can denote what's the priority of the traffic, right? We can see that it, certain bits are reserved, right? And then you can see if we tag it with 5, and this should give you some kind of application, right? Video conferencing, call signaling, high priority, medium priority, or even best effort. Best effort just means, hey, I'm going to try to put it across the network, and we're going to hope that it gets there.
Cross those fingers.
Right. So this is where they talk about class of service. All right. Now, if you move up the OSI model by one layer, this is where we get into some of our other stuff, right? You'll see that they have what's known as the diff-serve code point. Now, this is a layer 3 technology that allows us to implement quality of service. And to kind of understand what's going on here, this is just a basic IP header, if you will. If we could take a look at this, and you can see that there's some different information here, right? Down back here, essentially, this is all going to be encapsulated by the frame, right? So we're moving up to layer 3 here. And inside of this, you have your version in your IP header, you have your type of service, and this is an older field. This kind of predated our current quality of service implementations. You have the length there as well, and we look at you have version and length. You've got the length of the IP header. You got the identifier, the ID, if you will. Offset for fragmentation, time to live, how many hops is this going to go through before the packet's discarded. Protocol is just what transport protocol we're using, and then you have like an IP checksum as well, and then your source and destination IP, and then finally your data. All right, so big old long drawn out thing to talk about the IP header, and in that IP header we have the type of service. Now, in the earlier days, they were using something known as IP precedence, and IP precedence was a 3-bit field, and it was kind of limiting when we talk about it. It didn't allow for a lot of flexibility because the rest of the bits here in this 8-bit value were unused. Today, however, we use what is known as diff-serve code point to implement quality of service, and DSCP is what it's called. And with the diff-serve, that 5-bit field, it allows us to define things like the priority type and even things like or the probability of being dropped. And that is that's an interesting thing that type of service didn't have, right? Diff-serve just identifies the traffic. It places a classification on the traffic in the IP header, and then finally allows for greater classification, including the drop probability. Now, if you need to see this information too, as you go on to more and higher level certifications as you go into your networking, you'll definitely learn about this more in Cisco. But this is what we want you to know for now, the diff-serve code point. And Zach, there are tons of these DSCP codes. And again, because 5 bits, you've got a lot more flexibility there. You don't need to know all of the individual codes, and just kind of remember for the exam why I would see your DSCP, right? What would we use it for? Again, a lot more flexibility than the earlier 3-bit IP precedence. Now, moving on, there is another, I did look here in my notes, and there's another topic that I want to mention. I know we're running at the end down here, but I want you to know 2 concepts: bandwidth throttling and rate limiting, right? Mm-hmm. Rate limiting is, again, that shaping that we've talked about as well, right? That's part of traffic shaping. The other one is bandwidth throttling, and bandwidth throttling is slowing the amount of bandwidth that can be consumed. All right,
like using a throttle.
It's exactly why they call it throttling, and this is one of those things that when they got into the net neutrality debate and stuff like that, they're like, oh, ISPs are going to be slowing down people that are streaming traffic, right? Because they were looking and. Again, I think I heard one statistic that 70 to 80% of all of the bandwidth was being taken up by streaming media. So they're going to say, hey, we're going to reduce the amount of bandwidth that we allow people to stream media for, so that they're not the heavy bandwidth consumers over the other people that are maybe trying to get work done. So throttling, again, just like in CPUs, we say throttling, those of you that are coming over from 8+, we're slowing the rate of the bandwidth down, right? Rate limiting is outbound of your network, from inbound to outbound, if you will, and that's slowing down the amount of traffic or the amount of bandwidth that any one person or one device might be consuming.
That's fantastic. Well, Network Performance Concepts. Love this episode. A lot of great information. In fact, Wes has done a wonderful job with the entire series of CompTIA Net Plus. Make sure you watch each and every video. And when you're in that course library, there's hundreds of other videos there. They're all designed to help you go further. And tell everybody you know about IT Pro TV, because IT Pro TV is binge-worthy. I'm Zach Memis.
And I'm Wes Bryan.
And we'll see you again soon.
Thank you for watching IT Pro TV.